Cool, it's working. Hi everyone. Is everybody still awake? No? It was a long day, right? Okay, luckily we got a light topic about just cluster coordination. Let's see where we can go and take this and what you want to see a bit as well, or where you're coming from. So, I'm Philipp. I work for Elastic, the company behind Elasticsearch. We do a lot of cluster coordination and we fight various problems and things that we have improved over the time in our systems. And I want to dive a bit into that and like cluster coordination problems in general. So, who already knows or is using Elasticsearch? Who knows general distributed system stuff? Who knows stuff like the CAP theorem? Okay, that's not everybody. Should we quickly repeat the CAP theorem, or is everybody else asleep already who didn't raise their hand? Let's do it. Okay, let's start off with the CAP theorem. Or what do you know about the CAP theorem already? It's like you have these three attributes, consistency, availability, and partition tolerance, and you can have two at most. And by the way, two at most is really the right thing, because if you design a system badly, or if you pick certain trade-offs, you might only have one or even zero of those attributes. So it's not like a guarantee. It's 2 out of 3, it's not guaranteed. It's like best case is 2 out of 3. And the attributes that you have is consistency, which basically means at one point in time, you have one view over all the data in your cluster, or over all the copies and all the nodes in your cluster. They have at one point in time, they would all give you one consistent answer. So everybody or everything would give you the same answer at one point in time. Then you have availability. Every node that is reachable over the network should answer your queries. It cannot just decide like, hey, I'm not sure about the rest of the cluster, I will not answer. That's not an option there. And partition tolerance is pretty much a precondition for any distributed system. So all we're talking about is distributed systems where you have more than one node. And the partition tolerance is basically that the network can just break in the middle and like parts of the nodes cannot see each other. And there was Brewer's conjecture of the infeasibility of the CAP theorem was a very widely known paper. And it's actually a very easy paper. It's not lots of math. It's very constructivistic, like it's just showing like, let's assume we have 3 nodes in our cluster and we have a partition tolerance right now. The network broke in the middle. So we have 2 nodes on one side and 1 node on the other. And they currently cannot see each other. And you never know, like, is this one node dead or is just the network down in the middle? So you never know that. And then the idea is you write, for example, to these 2 nodes here, you write some data and you're in the partition tolerant, sorry, in a partition, so your system needs to be partition tolerant. And now when you write to these 2 nodes, the system has to decide, am I available or am I consistent? Because this other node here now has to decide, if I get a query right now and I cannot see the other 2 nodes, will I answer? And if I answer, I know that I might not be consistent because I might not see all the data that has been coming in over here because I cannot see them right now. That is, then you're available, but you're not necessarily consistent. The other option would be the node wants to be consistent and it says like, I cannot see the others in the cluster, so I will not answer your query. And then you're not available because you're basically stopping answering queries even though you could in theory. And that's one of the base problems of distributed systems, that sometimes it's very hard to know what is going on in the rest of the cluster, and then you need to pick how you react to certain situations. And if you have kids and you want to explain the CAP theorem to kids, it's a bit like Robinson Crusoe, where you know Robinson Crusoe is on his island and he's partitioned from the rest of the world. And then if a ship comes by and asks him a current question, he would have to decide, am I consistent or am I available? Because either he answers the question and then he is available, but he's not consistent with the rest of the world potentially, or he's not answering, then he's consistent, but then he's not available in the sense of answering questions. And that's the idea of the CAP theorem, which is one of the founding problems in any distributed system. That's just one of the problems that you might run into. So generally around, specifically since I have some demo code as well, and so that everybody knows what we're doing here. The concepts we have in Elasticsearch are, I assume everybody has an idea what a cluster is, right? So you have one thing that can answer your queries. You can just send your queries to that cluster and you will get an answer back. And you don't really care how that is structured internally. And then the cluster is made up of nodes, individual Elasticsearch nodes in that example. And the smallest cluster would have how many nodes? One, exactly. Not really a distributed system, and also not really highly available because, well, one node, and if that one node is gone, it's down. But the smallest cluster has one single node. But most clusters, like production clusters, will have at least 3 nodes because that's the smallest highly available system that we could have. And then we have an index. This is pretty much the related things that we put together into a so-called index. An index could be split up into one or more shards, and one shard always lives on one node. So the sharding is basically the concept of how to spread out data over more than one node in one index. Then you have a JSON document that's pretty much what you would always expect JSON, and every document has an ID, and otherwise we won't care so much about that. And these are kind of the base concepts of what we want to have and what we're using. And now we want a bit to go into the cluster coordination. So what even is cluster coordination? When I say this word and have it in the title, what did you expect to hear? What might cluster coordination do? Sorry?
How it is distributed on nodes?
Yes. So that is correct, like how it is distributed, yes?
Track the state of the nodes in the cluster? Track the state of the nodes in the
Yes, for example, as well, yes. So my easy answer out of that one is the cluster coordination is keeping track of the cluster state, which will not help you much if you don't know what is the cluster state. But the cluster state is basically the metadata that you have in your cluster. That might be, you have some cluster settings. You have, for example, configured some logging configurations in your cluster, or various other things you can configure in your cluster. You have the indices where you store your data in. They have some metadata. What might be metadata around an index?
mapping.
Yeah, the mapping, exactly, the mapping, for example. So it could be the mapping, it could be also like synonyms and many other things that could be in that state. And then there is lots of more stuff that we try to keep track of here in the cluster state. And you can actually check the cluster state and see how large it is and what is all in there with one API endpoint, cluster state. And so that I don't just talk all the time, I have a very simplistic demo cluster running here. It has, or it should have 3 nodes. You can see we have 3 little nodes here. They have an ID, they have 680 is the version number I have on those. One of them is a master node. We'll spend a bit of time on that part afterwards. And you can just see their name. This is just a Docker Compose setup, so it's pretty easy to work with that. And we'll actually stop them, start them, upgrade them, and do all kinds of stuff to that little cluster. But we'll get into the configuration a little later. So one thing that might be interesting is, first I store a document, so you can see my index is called a test index, and I store my document in there. And then you could say, check like, how is the health of my cluster? It's green, so my cluster is doing well. And you could also check the cluster state. And this is very hard to see, but on the, or you don't even see it at all here, but this is an extremely long list. Like I could keep scrolling here for a long time. This is the cluster state. This is the thing that we're mainly talking about today. So the cluster state knows, for example, which nodes do I have in my cluster. And you can see we have an Elasticsearch 1, 2, and 3 here, or 3 and 2. We have these 3 nodes. We have the metadata. We have lots of mappings, which you mentioned already. So we have all this kind of information in the cluster state. And it's a very long list. One of the interesting things is we have a version here. And every time we change anything that is in the cluster state, that version will be incremented and then shared to all the other nodes, for example. So if I say I want to create a new index, let's remove the T here because it doesn't matter much, and I index that, then the cluster state will go from 38 to 48. So it did a couple of other things here as well. So it didn't just move one further, but it created the mapping, and then it had shards, and then it had to move the shards from an allocating state to a ready state. So these are all changes that are tracked in the cluster state and are broadcasted to everybody else. And this is basically how the distributed system keeps track of what is going on and what the state is. And one of the probably more confusing things is, does this have anything to do with the actual data that I have in my cluster? No. This is totally different. Like the cluster state is just the meta information, and the actual data that you store and search, that is kind of a different kind of information. And those are two different things, and they totally work differently, and how they are being managed. That's what you should always keep in mind, that the actual data, like when I store some data or when I retrieve that, that's not the cluster state. That might influence the cluster state because that write operation creating a new index might update the cluster state. But otherwise, when I just read or search a document or store one, it doesn't influence the cluster state itself. But the cluster state is basically the foundation, or it's more or less the map. It's like I have a lot of nodes, and then I have some shards somewhere, and I need to find those shards. And that is in the metadata and the cluster state of how to get there. And it knows when I create a document, what is the mapping, so the schema from a relational world, basically. How should I store that data and how do I interact with that? Or how does logging work in my cluster? All of that is part of the cluster state, but it's not the actual raw data that you're interacting with. And those two work differently. But we'll focus on the cluster state today. So, one thing that is very important here, only move forward. There is no rollback. You cannot go to a previous state of the cluster state. And do not lose data here. Like if you lose data of the cluster state, your cluster will be in a very bad state. For example, what would be worse, if I lose a single document or if I lose an update from the cluster state? Any guesses? Sorry?
It will be worst. I mean, meaning the update of a state may be causing some like data inconsistency on other nodes. If some nodes missing like the changes.
So, as always, the answer is it depends. And that's when you normally start charging lots of money. But here, generally, we would assume that the cluster state is much more sensitive because the cluster state might include like, oh, we have an index or a shard somewhere. And if you lose the shard, you might lose thousands of documents with that one shard. Whereas if you lose one single write operation or one single search operation, it's bad. Some user will be unhappy, but it's at most one user. Whereas if you lose something out of the cluster state, your cluster will just probably lose massive amounts of data or not be operational at all anymore. So anything related to the cluster state for us is the much more critical thing. Like single documents are bad, but they are like not critical. They will not kill your entire cluster. The cluster metadata is what might kill your entire cluster if you do it wrong. So don't get those wrong. So, yeah, I've just shown you that was the cluster and the cluster state and the cluster metadata that we've looked at. And when we talk about how the system works with the cluster state then is it has three main components. First off, it has to discover other nodes, it has to do a master election, and then it has to publish the cluster state. And we'll probably spend most of the time in the master election process, I would say. So the internal protocol we have for using that is called Zen, or by now Zen 2. So we've had Zen for a long time, and Zen was basically Shai, who started Elasticsearch in 2010, put something together. And we've been kind of like patching that up over time, and like we found one bug and we tried to close and fix that bug, and then we moved on and we fixed another bug. And now in the latest version we have redone Zen, and now Zen is called Zen 2 because it's a new implementation. And the idea is that obviously it's all better, like more reliable, safer, quicker, all those attributes should be applied. Hopefully we managed, but we're pretty optimistic that we did. One thing is that discovery is not pluggable. That's why we generally don't really talk about Zen so much, just we call it discovery because, well, there is only one implementation. Our implementation now is called Zen, but you could not like put in another plugin and replace it with something else. It's the one that is in there. Depending on what version you get, you will get either the original Zen or the redone Zen 2 that has been developed over the last, I don't know, 2 years or so. And the idea is that your master node is pretty much like the capybara, that is all chill, and regardless of what is happening around it, like all the other nodes can walk around and they can create data and whatever. Like everything can be chaos, but the cluster state, and especially the one master node that you have in your system, should be like the capybara that is just relaxed and just sticks to whatever it's doing, whereas everybody else can be in chaos. That's the general idea. So we had these three phases, or the three most important things in the cluster that the cluster has to do to be operational. The first one is discovery. What are the master eligible nodes? And maybe we should take a step back and ask, like, does everybody understand when I say master eligible what I mean? So in Elasticsearch, there are multiple node types. This is kind of common for various distributed systems that you have different components. For example, one component that we have in there we call master eligible. This is a node that could become a master. And every cluster can only have one master because that master is keeping track and maintaining the cluster state, like where are the shards. And it can only be one that keeps track of that. And master eligible ones are out of this pool of master eligible nodes, you will actually get the actual master node. So what you generally have to check is what master eligible nodes do you have, and is there already one master that you could join? Or do you need to create a new master node and vote for that one or set that up in the cluster? What other node types would there be around in Elasticsearch other than master nodes? Any guesses? No, there are no slaves, no. We're a slave-free society. Yes, so we have data nodes. The data nodes are basically the workers. They keep the data. This is where your actual queries are being served from and where your data is being stored. We could have client nodes or coordinating nodes, which just coordinate stuff. We could have ingest nodes, machine learning nodes. We could have other types, but they are not that relevant. How many roles could one node, one Elasticsearch instance or node have in our system? Only one or more? More, yes. By default, a node is both a master eligible node and a data node and has other roles as well. But those are the two most important ones. In a larger cluster, you might want to split them up. Anybody who knows why you might want to split them up? Sorry? Reduce the load? Yeah, reduce the load is one thing. The thing is the cluster state is very sensitive. And if the cluster state is not available, then your cluster will be in a very bad state. And Java has this unfortunate thing called garbage collection. And if you have a very long garbage collection, your node might not react. And then your whole cluster gets in an unstable state. And that's why you might want to break out these master eligible nodes onto dedicated nodes. So they only keep track of the master or the cluster state, but they don't have to do or work on the actual data. And that will normally avoid that you have long garbage collections because there's not so much data going in and out of them, so that should be easier on the nodes. But that's just an architecture point of view. So the general idea is the discovery phase looks something like this. We have 3 nodes, and you can see that each node is thinking something. Like each node is thinking, this is what the cluster currently looks like. And then they need to reach agreement what the cluster actually is looking like and does. So you can see this one here thinks that there are actually 4 master eligible nodes in our cluster. This one here thinks we have 3, and this one here thinks 2. And now they need to reach conclusion of what actually is the state and what makes sense to form a cluster. And in the end, hopefully, they will each see each other. They will not be able to find that pink node anymore, so they will probably ignore that one. That node here will see, oh, there's actually a yellow node as well. So they will, at some point, they start pinging each other. So each node will start to ping the other nodes. And then they will hopefully see what state they're in. By the way, you don't need to ping all the other nodes immediately. It's normally enough if one node pings another node and that node knows other nodes, it will respond with, hey, yes, I'm here. And by the way, I know these other nodes. If you have not seen them, try to contact them as well. So there is like this bootstrapping mechanism where nodes help each other out finding what is available in the cluster. So that's kind of the idea. You start your cluster up, and then the nodes will try to find each other to form a cluster together. And the general conditions for forming a cluster are, does anybody know that? There's a cluster name that needs to be the same on all the nodes. If you don't have, sorry? Replica set is, so we call it replication shard, but that is a concept from the data storing world again, whereas this is the cluster state world now. So to act or interact with data, there is a primary shard and one or zero or more replica shards. But that's kind of this data world, and that's separate from the cluster state. So the primary shards and the replica shards is a different concept than the cluster state. This is really just for the master eligible nodes that they find each other and they form the initial cluster. And then any non-master eligible nodes can also join a cluster that the master eligible nodes have formed. So basically the foundation are the master eligible nodes, which normally in a production setup would be 3. They form the cluster, they vote for one master, and then that master would add all the other nodes and change the cluster state to form the entire cluster then. So they should reach agreement on that. And up until version 6, we had this setting here, discovery, send, ping, unicast, hosts, which was very long, and it had send in there, which was kind of unnecessary. We have renamed that now. The old one is in the version 7 still around, but it's deprecated. We just call it now discovery seed hosts. And then was host provider, and then we have discovery seed providers. These things are basically doing the same thing. They're allowing you to set which nodes are available in your cluster and to find other nodes in your cluster. But this one is basically a static list where you say these are the IP addresses or DNS names of the other nodes to find. And this one is dynamic. Like you can provide a file, you can provide, for example, a label on EC2 instances, you can provide settings in the security group of EC2 instances so they find each other, and on Google Cloud we support the same thing. So this is just in cloud providers or in cloud instances, you probably don't want to hard code any IP addresses or DNS names. There you want to provide a more dynamic way of actually figuring out what is available around here. Whereas this one is just a static list. This is the easy way where, we have these 5 hosts and we just wire them together. So they find each other. And then they need to agree. The nodes that find each other, like the master eligible nodes, they will start pinging each other and say like, okay, we are 3 now. Do we have the same cluster name? Only if they have the same cluster name, they will actually start a cluster. Otherwise, they will say, well, we're in a different cluster because different cluster names, we will not form a cluster. By the way, a long time ago, we used to have a different concept or an additional concept on top of that. Does anybody remember that one? We did broadcasts on the local subnet. But that was, I think, changed in version 2 or so a long time ago. So if you would start more than one Elasticsearch instance on the local subnet and kept the default cluster name, they would ping each other and automatically form a cluster, which was very nice for demos because it would just work and you would have magically a cluster. But sometimes it didn't work the way you would expect or want it to. Because, for example, if you do a training, I had that in my trainings, that everybody would start up their one-node cluster. And they thought, well, it's a one-node cluster, and then the entire classroom was forming one big cluster. And then one person would add some data, and at the same time, some other person was deleting their data. And it was pretty much chaos because it wasn't so obvious that it was one big cluster. So by now, you need to be explicit. You need to say, like, one of these 2 methods is how you actually find the other nodes and to form one cluster to avoid trouble. Yes, so the idea is you have one leader and everybody else is following the leader. That's the general idea of the master node because only that one keeps track of the cluster state. So when you have, let's assume we have the simple example, which also is okay for production setups. We have 3 master eligible nodes, or 3 nodes in total might be fine as well here. What are the options to form a cluster now? So you could either do this, where these 2 here say like, hey, we found each other, we will form a cluster. And can they do that without the 3rd one? No, they can. Yes, they can. Why? Because they are the majority. The idea is always you need a quorum or majority in the cluster to do anything. Because the guarantee that you avoid that problem with the cap theorem that I've explained initially, which the so-called split brain was, we're solving it through a quorum. So if you have 3 nodes and you have like 2 here and 1 here, to ensure that they will probably work properly together is that those 2 here, they are the majority, so they can do stuff. Whereas the other one says like, I'm only 1 out of 3, so I'm the minority. I cannot do anything on my own. I need to get in touch with the others until I can do something. But the other two, they say like, we are the majority, we are 2/3 out of the cluster, so we can do stuff. So you could form a cluster where these two here start forming a cluster, and at some later point, maybe this one here sees that and says like, okay, I will join that cluster. Like, I'm on my own, I cannot form a cluster anyway, I will join that other cluster. And could also happen the other way, and obviously there would be a third way that these two start the cluster and then the other one joins, or all three could work together. I hope this is visible. Would this be possible, that you form one cluster here and one cluster here? No, that's not possible, and that would be a major problem, because then you would basically have like two different clusters. Like, this needs to be one big cluster, that's possible, or you always have the majority. And unless you have a majority, you cannot do anything. So what would be the majority of two nodes? 2. Does that make any sense? Not much, because the goal is generally you want to have high availability. And if you have 2 nodes and only 2 nodes can form a cluster, as soon as one is gone, your cluster is dead anyway. So that's why 3 nodes is the sensible form, that you have 3 nodes and then 2 out of 3 can still form a cluster and keep operating, so you can tolerate the loss of 1 node. How would that behave with 4 nodes? Sorry? Yes, but we are not winning anything, right? Because we have 4 nodes and we can tolerate the loss of a single node again. So the next step where we could go is 5, then we could have the majority of 3, then you could tolerate the loss of 2 nodes. But you basically need an odd number, and then you can tolerate the loss up to the minority of nodes to keep operating. Otherwise, it doesn't make much sense. That's why 2-node clusters and 4-node clusters are normally not a great choice. And every time I see somebody who says, like, we have a 2-node cluster, I'm like, maybe you're doing this wrong, or I'm not sure. Like, let's talk why you're doing this, because I'm not sure. Okay. So yeah, that would be the 4-node cluster, and here you would have the problem, 2 out of 4 is not a majority, and then you could have 2 independent clusters, so this is not going to work out well. This is the forbidden state, don't go there, don't do that. And then, to do that, in the past we had a setting where the user would set that. Discovery send minimum master nodes. So we would basically say like, hey, our cluster has 3 nodes, and I set what is the minimum master nodes in a 3-node cluster then I need to configure? 2, because 2 out of 3. Do you normally trust your users? Or your system administrators? Because that's something we have seen a lot, that many people were either not setting this, or they were not setting it correctly. And then your cluster is in a very bad state. That's kind of the trust problem, that maybe you should not trust people to set that, because it's kind of an important setting, and if you do that wrong, your cluster will be in a terrible state. For example, if you have 3 nodes and you keep minimum master nodes to 1, and your cluster breaks apart, so you have a 2-node cluster and a 1-node cluster because they have broken apart, and your application writes to that one and to that one, there is no automated way to merge the data back together. Like, you will manually need to fix that somehow, because there's no automated way to mediate it anymore. So then you're pretty much on your own. Don't do that, don't get there. So let's try to move. So this was version 6.8. This is the previous major one. That still has Sen. Let's move on and go to Sen 2 to see how that one is going. So we still have a cluster state. We are now still at 48 because we didn't do any changes. Let's do a change. The first thing I want to do is I put my cluster state into, I basically make sure that when I restart the node, it will not try to reallocate the replica shards. Because the replica shards, that's the actual data that I have in my cluster, and I want to make sure that it's not trying, because it figures out like, hey, one node went missing and it had some data, and I will try to recreate the data somewhere else. But that's totally unnecessary, because I'm just restarting the node and it will come back very quickly again. So we'll stop the cluster from doing any unnecessary work basically here. I can also say like, hey, I want to make sure this is a synced flush, so basically this means the shards that keep the data have a sync marker in them so that the recovery when the node starts up again is faster than if we wouldn't set that. This is just a preparation or a best practice when you do an upgrade. And you can see these are all the indices that I have. They all have that marker set now, so it should be pretty easy to upgrade them. So what we need to do is, since I said this is a Docker Compose setup, first we upgrade the version. So I'll keep it simple. We go from 6.8 to 7.1. So we'll change the version number here. And I will restart the Elasticsearch 3 node now. Since this is a Java process, it will take like 25 seconds or so until the process is actually up and running. And in the meantime, I can show you how this is actually wired together. So you can see here Elasticsearch 3 probably died because here that was already the restart. But the node is already restarting, so it should be working in the background and coming up soon again. So what you have here is basically we have one Elasticsearch, one node. I say this is the container name as well, and I say this is the base image. Here we have the version. This is coming from the .env file. That's why we have it in a single place, and then everything can be upgraded through that automatically. I just say like, hey, this is my Docker cluster. I just give it a name. I give it the node name Elasticsearch 1 so that that is consistent. And then here you can see these are the two settings that we had in Elasticsearch 6 or lower. And actually, before the restart, I should have changed that. Let me quickly fix that. So what we do is we disable the two settings we had here, the send ping unicast hosts, that was the old setting, and the minimum master nodes, that's also the old setting. What we want to do is we want to say the seed hosts, this is where the other nodes are in our cluster. I just want to see those. We will leave this setting here out for now because we will get back to it later. So let's do the same thing for the second node. Like, otherwise, the nodes are all the same. So I'm just removing the settings from the 6 version and add the new 7 version to restart them. Otherwise, you will get deprecation warnings, and it's just, going forward, these are the right settings that you want to have. So I fixed my configuration, and let me, no, that's not what I wanted. Let me restart the node again. So now, while the node is being restarted, let's see how our cluster is doing. So we can see we only have 2 nodes now because one is being restarted. You can still keep reading your data. You can even write some data in the meantime. So we could, for example, create one Elasticsearch 7.1 document. It doesn't really matter. You can work with your data, and it will take like 25 seconds or so until the node is back up and then joins the cluster. And the node that is coming back will basically figure out that, hey, there are the other nodes, they are a cluster, they have a master, so I will just join them. Excuse me. So that node will not start its own cluster, it will just join an existing cluster and an existing master node. And now we can do a rolling upgrade with the other nodes, so we'll just replace node 2. It's pretty quick. They discover that one node is falling out of the cluster, and then it's just coming back. So this will take another 20 seconds or so. Now we have a mixed version cluster, so we have 7.1 and 8.6, and they just happily form a cluster and will answer your queries. Does anybody know the upgrade path of how you can actually upgrade do a rolling upgrade? So generally, you need to be on the latest minor version of the previous major, which is right now 6.8, and then you can go to any version in the next major version, so 7.1. You don't have to go to 7.0. You can just skip whatever other minor versions there are. You can just go to the latest or whatever version you want to use. You could go from the latest minor in the previous one to whatever is the current version now. Yes?
Is it possible to upgrade, for example, from 6.4 to 7.1? Or
no. You need to be on 6.8 to go to 7.1. Mm-hmm. You need to be on the latest or last minor version in the previous major. And we made a bit of a mistake, or I wouldn't call it a mistake, but we didn't want to release a 6.8 actually. We thought that 6.7 would be the last version. So here it's a bit different than in most other cases because you can upgrade 6.7 to 7.0 and you need to have 6.8 to go to 7.1. Because we didn't plan that release and those two match up. But you can go from 6.8 to any 7.1 or later. That's the upgrade path that works. And while we have been talking here, you can see that other node has come up. I will replace Elasticsearch 1 now. And so that we don't have to wait so long, I will also replace Kibana at the same time, because obviously there's a new Kibana version as well. And everybody complaining that a Java process takes a long time to start up, wait until Kibana, which is a node process, comes up, because that's at least as slow. We can just, because we cannot see much else at the moment, somewhere here you can just see like, okay, Elasticsearch 1 is trying to come up, and you will see multiple steps how this is initializing and then starting up now. And again, it will take like 20 seconds or so until it's joining. And like this scenario was pretty easy. Like the rolling upgrade, we always had a well-formed cluster with 2 nodes. So the third node that we were replacing could always join the existing cluster. So that one was easy. And yet you can see here that node changed from red to yellow because it found the other nodes and found all the data that it wanted to have. Now Kibana is also coming up, and at some point Kibana should be listening and available again. So that is green, let's see. That will need a hard refresh because, well, new Kibana version. You can see we've changed the colors again because the design team needs to change the colors all the time. Where were we? We've been here. Let's see, is our cluster complete? Yes, we have a 7.1 cluster all the way now. You can see we can. Actually, are you surprised that the Elasticsearch 3 node is a master node now, or not? Yes, anybody surprised? Nobody surprised? You shouldn't be surprised, because initially when a cluster starts, one node becomes the master node. But when I did all these restarts, we started with the Elasticsearch 3 node, which joined the existing cluster, so it wasn't the master node. And then it will depend on, like, is Elasticsearch 2 or 1 the previous master node? But at some point, I restarted that, and the other nodes, like, the cluster was formed, and then the other nodes were joining that cluster, and then Elasticsearch 3 was kind of like the first one that was there, and all the others were joining back to that. So that one has the highest chance of being the master node. And Elasticsearch 1 has a 0 chance of being the master node now, because it joined the cluster last. So it would only join an existing cluster, so you shouldn't be surprised if that setting is. I will change the cluster allocation again, because now all the shards can be allocated freely again. And now we can say, oh, we have an Elasticsearch 7 document, and insert that, and that's good. I think I've added that document twice now, but doesn't matter. So you can see all our documents are there. We did a rolling upgrade. Our cluster was fully functional. Everything was good. So what happens if I now stop that cluster? And let's say I want to bring it back up. Will that work? Will that not work? Especially since we removed these minimum master nodes. Like, will this be able to form a proper cluster now? And yes, in version 7, it will do that, because what it does is it stores in the data directory, it stores what the cluster looked like when it was shut down. And it knows, okay, this was the cluster that I have seen before. And so it knows that there are 3 master eligible nodes in the cluster. And it expects, when it comes back up, that there are still 3 master eligible nodes in the cluster. So it will know I need to have at least 2 to form a proper cluster, and then the cluster will just fix itself and should work. And yeah, I'm not sure how long that one will take, but let's see. If I start querying one node here, let's say the Elasticsearch. This is the Elasticsearch 1 node, if I remember correctly. But yeah, it's not up yet because, well, they're still starting. It will take a couple of seconds. Here you were seeing, like, okay, the Elasticsearch nodes are fighting their way up. They should be forming a cluster any minute and should be responding on the command line soon, hopefully, as well. If my demo doesn't break, you never know. Come on. Okay, yeah, stuff is happening. I see stack traces. Let's hope this is a good sign. Yes, okay. You can see my node here is backup. You can just check if you use the right command, it will show. And you can see now our cluster is back up, everything still worked, and I'm not sure if Kibana is up yet or if that's... Kibana is up as well, so we can also use that. So that just works. But it's not always that easy. So we've seen the restart demo as well. There is this other new setting called cluster initial master nodes. And you need that one for the very first time and only for the very first time when you start up a new cluster. So when do you have a new cluster? When the data directories are empty, like there is no previous data from the cluster. So we've seen the cluster is back up, it's all working. You believe me that it's okay, right? Not Zoom. Go away, Zoom. So what I do now is I stop the cluster again. We blow away the data directories. And I try to restart it again. What do you expect will happen now? Will the cluster still be coming up or not? And no, it will not be coming up because I haven't in the configuration here, I haven't set this cluster initial master nodes where you basically say the master nodes are 1, 2, 3, these are the master eligible nodes, but I haven't configured that. And since we don't have any previous state from which we could infer that, this is now a brand new cluster. It has never seen the other nodes. It has never seen the cluster state. It doesn't know what other master eligible nodes are there. So this will not be able to form a proper cluster now. You would need to enable this setting here on at least one node. So this one here. So we can add that on all three. We can start it in the background. We don't actually have to wait for it to finally happen. What I really want to show you is, go away Kibana, I need an Elasticsearch log. No, this is not one I want. Somewhere, let's see, Docker PSA. And I need one Elasticsearch node. Let's take that one. Docker logs. This one here. This looks good. This is the message I want. And this is probably totally unreadable for you. But what you have here is, and this one here is, if they cannot form a cluster, it's another thing we try to improve over time, is now that the messages are much better. So this will issue, I don't know, every 30 seconds or so, I think. It will give you a message that it couldn't form a cluster because it says like, the master has not been discovered yet, and this node has not joined any other previous clusters, and you have not set the master initial nodes, so I cannot form a cluster. So the logs are now very explicit of what is going on. And it's also trying to help you out basically by saying, hey, here are these other nodes I have seen. Like I have an this was Elasticsearch 3 or so, I think, and I've seen Elasticsearch 1, and there is an Elasticsearch, there's some other Elasticsearch number in here. If I can see where's my curly brace closing? Yes, here. Here's Elasticsearch. Okay, then this must be the log from Elasticsearch 2 because there is a 1 and a 3 that it cannot join. So these are the other nodes that it has found. But it could not form a cluster because we have not configured it correctly. But this is the only time you need to have this setting because once it has formed the cluster, it's good, and it can just go wild from there and form the right cluster. Okay. You can set the list of the master eligible node names on more than one node, but keep them consistent. Like if you put the setting master eligible nodes on the different nodes, and then you put different number of nodes in there, your cluster will be in a bad state because it will not know what is the right number of, or what are the right master eligible nodes. So if you set that, set it consistently. Once you have joined the cluster, the setting is ignored, So as soon as you have formed the cluster once, you're good. And you don't have to set that actually when you join an existing cluster because, well, you're just joining the existing cluster and the cluster will just take care of that. You also need to set that when you do an upgrade from 6 to 7, which we have done, if you do the rolling upgrade, it's not required to set that. If you do a full cluster restart where the new mechanism basically has never seen the cluster, then you need to set that setting. Otherwise, it will also be confused and say like, hey, I've never seen which other nodes are there, how could we even form a cluster? Yeah, we've just done the cluster rebuild, which failed. We could redo it again, and then it would form the cluster, but I guess you believe me there. That was the error message that we've seen, and this is just as badly readable as the other one. I will try to split it up into more slides in the future, I guess. So the result is that you have a much safer cluster operation because you provide the list of master nodes or master eligible nodes initially, but then the cluster will figure everything out. And the user doesn't have to set the right number, you just have to provide the master eligible nodes, and it will then just calculate that and do the right thing. And what is also much safer is you can now dynamically scale the cluster. Because if you say like, hey, we have minimum master eligible nodes 2, and we scale the cluster from 3 to 5 nodes, 2 is suddenly not the right setting anymore because you need 3 nodes to have a majority. And you would always need to update those settings. And that is not necessary anymore because the cluster will keep track of that now. So master ineligible nodes, don't care. If you add master eligible nodes, it's also fine, just add them because the cluster will figure that out. The only thing that you should not do or where you need to be careful is if you remove more than half of the nodes of the cluster, it might get into a state where it says like the majority of the nodes is missing, like I cannot form a cluster anymore. So what you would need to do is if you want to remove many nodes from your cluster, for example, if you want to go from 7 to 3 nodes, and then you would remove 4, the majority, and all are master eligible, then you would just remove 1 node, the cluster figures that out, or basically you can remove 2 nodes at once, then it would figure that out, and then in the second step you would remove another 2 nodes. But don't remove the majority of the nodes because then the cluster would say like, I'm not sure if this is intentional or if I'm broken in the middle and there is the majority somewhere else, because it just couldn't handle that. Yeah, and then once the cluster has formed, this is very short, don't worry, you can actually publish the cluster state and broadcast that to all nodes, which would look something like this. In a 3-node cluster, this is the master node, and it publishes the changes to the other 2 nodes. And as soon as it gets the acknowledgement from the majority, so this one applies the change, and this one says, yes, I apply the change as well. It doesn't even have to wait to the 3rd node because the majority has now applied the changes to the cluster state. And then it just tells the other nodes, hey, actually apply the change and commit the change to the cluster state, that there is a new mapping available now, for example. And then they will acknowledge that, and that is how the cluster state will develop. So basically, the master node will broadcast in a peer-to-peer fashion the cluster state to all the other nodes, and will tell them, hey, this is what the new cluster state looks like. Follow that. And each one of them caches that state and then receives the update and upgrades that. And by the way, this is not always the full cluster state. This is normally, in many or in most cases, just a diff of the changes of the cluster state that needs to be broadcasted. So if you add a mapping, only that one mapping will need to be broadcasted and not all the mappings that you have. Okay, to wrap up, hopefully or ideally, that's what the plan was, is that send to send2 is faster. Like node recoveries will be faster because we've been able to change timeouts to be lower now. It's safer because you cannot wrongly configure the send minimum master nodes anymore, and scaling is safer because of that as well. And it should also be more debuggable because the error messages are better now. And that's pretty much it. Are there any questions, even though it's so late? Yes?
I didn't understand why it's a problem to elect master from the very beginning, because if three nodes know about each other, maybe they can somehow elect master.
The 2 nodes in the beginning cannot?
No, 3. No, when as I understand from the very beginning,
Yeah.
when there is no data at all,
Yeah.
you start a cluster, no, it's, 3 nodes, and you need to set in your config which node is master by default or something
No,
like that.
you don't explicitly say which one is the master. You say like, these are the 3 ones that could be the master, and they will figure that out themselves. And with the 3, for example, they, as soon as 2 find each other, they will. There is a voting protocol. It's like either one is an existing master or they vote. And I think the vote is normally triggered. They generate the unique ID for every node, and the unique ID also has an influence who suggests first, who is trying to vote, and then there's a timeout. Everybody votes, and then they all agree on something. Otherwise, they will do a revote if 2 nodes try to become master at the same time. So there's also a coordination protocol for that, and it's guaranteed, or unless there is a very serious bug, it's guaranteed that there's only 1 master node. Because if you have more than 1 master node, then you're in deep trouble, and your cluster will not be functional properly. Cool. Did everybody learn something? I hope so. Otherwise, if you want stickers, I have a couple of stickers over there. If you have more questions, just find me. Thanks for joining so late today.